I'm very pleased to be here with you today, so smart people around. And today we speak about a hot topic in these days, that's Internet of Things. We start with a theoretical part before, and then we go inside industrial Internet of Things with a data distribution system, okay? And then we do some hand-ons to see how, by your own, can download this free trial of this framework created from a Silicon Valley company called Real-Time Innovation that has some headquarters in south of Spain as well. And then let's start. Let's go on about Internet of Things. Well, we know that in the first is the next big thing. They told me 2 years ago that was the next big thing, is still the next big thing. Actually, there's some market growing, and so there are a lot of growing opportunity in business and Internet of Things. Okay, and so these are the number of the billions of dollars that they are estimated in the next 5 years. The EU Commission has said that there are three big things in the next 3 years. One is security, one is artificial intelligence, and the other thing is IoT. We speak about industrial IoT. I think everyone has a smartphone and has some kind of IoT in his own smartphone. But industrial is something that affects our lives every day. For example, when you go to highway, there's a telemetry order for energy creations, so on. Okay, so we say that the 80% of HIP is how school IoT is consumer HIP, and the real thing that is used for our life is our cyber physical systems. So industrial things. So before you speak about thing, you have a suite of protocols that are currently used in the IoT. The first one comes from the web as a REST services called a COAP. Is you think the thing like a web of things, and you go directly with the TCP order, UDP protocols using this kind of REST services. So you register the thing, and they say, I'm in your, and I'm present, and I'm ready to get updated, and I'm ready to be updated. And at the end of the story, you don't register the thing. Okay? We are doing this overview of protocols in order to understand what is the right protocol for your problem. That's not Silver Bullet. Second protocol that is really used, that is a broker protocol. You have a set of producers, and you have a set of queues that the brokers manage in order to the consumer will be able to get messages. Okay, it's called advanced message queuing protocols, and you have two versions of them: one-to-one and one-to-many. You can do broadcast from the protocol as well. It's pretty broker-based, so I have several set single of failure, and after that we can go on. And there are several implementations around. The other protocol is MQTT. It's used mainly for telemetry. So you have a set of small devices, big set of small devices spread around, and you have to collect some data from there. For example, in the highways, we use it as a field in Barcelona for our highways and detect speed infraction, for example. And there is what to do. So here we see the differences and the between different protocols. And I did not yet mention in the review the data distribution system, because I will go later in that. So basically the architecture of everyone except DDS are broker-based. And sometimes you can constrain the topic in most of the time. Otherwise, with DDS, you can subscribe the content. But you can subscribe the content, you can as well filter the content. Filter the content means I don't want this set of things, a set of messages that the things sent to me, I get rid of immediately by default. And most of the them goes, okay, it's not correct to TCP or the reliable UDP, okay? And someone has, in the contract of the things, you can specify the quality of service that you want, okay? And most of them accept DDS as plain or standardized format, okay? DDS uses a codification because we need runtime, and we need that the receiver and the sender will be fast, okay? If okay, so as I mentioned before, there's no single validator for the serial one. Depends on your program, okay? And now we see one is better for one, and one is better for another one. So probably you want to choose AMPQ if you want to distribute work and not just information. You have such a broker, you said do this, do this, do this. And you can have just wait A to B, message from A to B, and then speed and performance are not so important, and absolutely you cannot permit yourself to lose something. Probably you want to use AMPQ, like said before, if you have sparse sensors around, little devices, to device communication, and you need some coordination between the devices in order to aggregate the information. And then you have a very, very small number of devices, and you have to think the information like a collection that comes from the devices and came to you. You need REST or COPE as well if you want to be always connect. So if the device is always connect, or and then you have so few connectivity points around. And I say my phone, my tablet, and so on. In all these cases, you can think about the thing as a REST, okay? And as well, the performance is not so good, so you have to. That's not important, okay? Okay, you need VBS when you have a deadline. You have a disaster to cope with. If it doesn't receive the things, information from the things, probably will happen disaster or something that you cannot permit yourself. And for you, performance is really important, really, really important. Because all the format of DDS is all compressed, so there's no, it's all binary format. And when you want to scale of the number of things. And now we see why DDS is scaling. So the main idea of DDS is that it's a kind of cloud, okay, and a set of reader and a set of writer as well. Reader and writer are decoupled, and reader and writer are subscribed to topics. For example, temperature is a topic. The alarm of nuclear power is another topic, and so on. So the application that use DDS, you have some kind of virtualized data space, like a bus, for example, and there is no broker in the middle. So you don't have to rely directly to the broker. It's the middleware that allows you to don't have any point of failure. Then the most important thing is topic. So reader and writer subscribes to topics, receive information from topics in this kind of virtualized data space. And then the topic has a name, a type, and a quality of servers. So you want to have some delivery guarantees if you subscribe to a topic. Or sometimes you want to have a more relaxed delivery guarantee for other topics. If a topic is really important, if a message does come and there's a disaster, you want a strong guarantee that the middleware enforces to you that that message will be flowed from writer to reader. And then the other thing is like it's in this case, you can think of DDS like a peer-to-peer system. Okay? That's dynamic discovery. So you can deploy DDS in your local network via UDP or via TCP, and you can deploy as well scaling on the cloud, okay? Especially with RTI DDS. This is what I was saying just before. So you can adapt your reader and writing to the protocols and as well to the topology of your network. It doesn't care. It's the middleware that works for you. You should trust that the middleware, following some mechanisms that we see later, will deliver with your guarantee the message from the writer to the reader. Okay, now we can go with the simple hands-ons. Okay, now we have a overview of the ideas that we can create something with the DDS, and we can see how to write a service, a reader, topic, and writer, with the middleware that RTI provides us. Actually, there's a code generation called RTI's DSS gen. And with this, executing this command, I need to define the model of the data that I want to model. I already done this. I have to define in an interface definition language structure. See, one moment. In this case, I define something simple, like the latitude, the longitude of vehicle, and an alarm. Okay? And executing the command that we have seen before, I have exactly, this information. This is executed you have this generated code for me that gives us the status, the longitude, and everything that I need. Okay? And the topic, for me, is the topic. And then I have the stub for the reader. Wait, it's over there. Sorry. It's over there. Publisher. That I call publisher in my case. And this is what we are saying is that DDS has a domain. A reader and a writer, they belong to a domain. And as they subscribe to a topic, and with this simple information, I do the setup of the data writer. And from the other part, I just write some information to the sample, to the reader. Okay? And with this, in 5 minutes, I've created a peer-to-peer system that works perfectly. Trust me. You can try, I say you record it, and it's fine. We can go on examples, and then we can do the famous code. Wait. Okay. The idea is do some kind of vehicle tracking, okay? And we have air fleet management in this case, air traffic management, and we want to have this structure. So the cloud that you have seen before is just a bus, okay? And we have a flight generation plan for each plane that is around, and we have an air traffic control guide and a radar generation. And we want to update from the flight generator the radar generator, the air traffic control guy. Okay? So the responsibility are the following one. The flight generation sends to the bus the flight plans for multiple aircraft. The radar receives the plan for multiple aircraft and tracks for the flights. Okay? And this happened. And then let's see the demo. Okay? So I go back. CPPD. Vehicle tracking. Wait for a moment. It looks if I have the sport and the DS home. I have still 5 minutes. Next. And then I go to scripts to launch first the tracking GUI. This is the GUI where the place where I want to track the latitude and so on of the planes. And then I will start the radar generator, flight radar generator. Okay. And then these are the latitude that's been updated. And then I add the flight plan generation. And I see some new updated over there. I lost the GUI. Yeah, this is the update. And this change latitude and so on. It's not so big. Now we can go. We can go to the read, and this is the communication inside the DDS. So I have a reader and writer and can communicate, in this case, in a local network, okay? But now we see that it can happen as well for wide area network or the clouds. The framework gives you some mechanism to communicate from one to another, and this is the radar is detecting the different planes that are moving and following their flight plan. Okay, I have just one thing. In 2 minutes, and we go back to the slide. Okay. Now we have seen these two. How does it work? And we can scale to the one. Okay. Basically, the framework provides you a so-called routing service from one point to another point that goes a direct connection from the first LAN to the second LAN with different domains. Reader writer belongs to one domain. Okay? It can go from the writer application in this case to this reader application. Imagine a temperature sensor from the first domain that goes and sends alarm, okay, for example, in a hospital, to another place. And you have the second domain that the doctor reads on the screen that's an alarm to another place. And are different networks or different places in the city, for example, and you can go there. Now, with the last development with the RTI Connext, we can scale more about this. We have a so-called discovery service. In this case, the discovery of everything comes through the routing service. In a local network, comes through multicast, generally. Sends packets to the multicast, and they discover the things. Okay? The reader and the writer, they are subscribed to a topic. But we can go more recently they have developed with a cloud discovery. So I have the same situation on the local network replicated with a different domain, and then one part of the middle probably placed in HU in Amazon that allows you to discover wide areas. Actually, it's really experimental. I tried this. It works and doesn't work. Okay? The rest works pretty well, as you've seen. My talk is finished. Thank you very much.